So I'll just introduce myself. Hi, everyone. I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So with that in mind, we're going to be talking about one of the weirdest, craziest features in 18C. That's polymorphic table functions. So as I said, what we're going to be looking at is polymorphic table functions. These were something that were added in 18C, and what they allow you is dynamically, at runtime, manipulate the shape of a result set. So what the heck does that actually mean? Well, you can now add or remove columns from the results of a query based on your input parameters. So you can change what the result set looks like. You can add more rows, remove rows, add or remove columns to completely transform a table into something absolutely crazy. At this point, some of you may well be scratching your head and thinking to yourself, well, why the heck would you want to do this? Why the heck would you want to add columns or remove columns from a table in the result set? And, you know, personally, I think there's relatively few general case situations where you can actually want to do this. So here's a few I could think of, and start off with a CSV to column converter. So let's imagine you're building some kind of generic CSV file importing routine. And each time you run it, you're reading a new file, and there could be different numbers of fields in each CSV that you read. And you want to spit those out into individual columns. So the number of fields in the CSV matches, or the number of columns in your query matches the number of fields in the CSV. So each time you run it, you're going to read a different file. You could have different numbers of fields, which means different numbers of columns. So polymorphic table functions is an ideal way to do this. You're manipulating the results, adding or removing those columns. Another use case I can think of relates to the pivot function. So this is a fantastic feature, and what you can use it to do is convert rows into columns. So it's really great, but it does have an Achilles heel. In order to do this conversion, you need to know what the values are in the rows that you want to actually become the column headings. If for some reason you don't know this, there's all sorts of clumsy hacks that you need to go through to do this process. PTFs offer you another way to do this, offer a way to kind of say, well, here's a query or whatever that's providing the list of the column names that I want. Use that to generate the new columns that we're going to get in the output. So I see this as probably being one of the most widely applicable use cases for this. Is dynamic pivoting is something that comes up fairly frequently. You know, probably at least once a month someone asks me about it. Finally, something I'm going to mention is something called top N plus. So this is something mentioned in the SQL standard. So this is where you've got your standard top N query. Let's say you want to find the first 5 rows, and then you have an extra summary row detailing everything else. So I've counted how many orders each customer's placed. I want to show the 5 customers who placed the most orders, most down to least, and then I want to have a 6th row giving me the total number of orders placed by every single other customer. So top N plus. Your standard top N with an extra summary row detailing, you know, counting up, aggregating, whatever, all the other data in your result set. I'm sure some people are going to come up with a whole bunch of weird, wacky, and wonderful use cases for this, and it may well be that there are some edge cases which you encounter which make this relevant to you. But for the most part, I don't think many of us are actually going to write these from scratch. You're probably going to take one of these examples. We've got some prototypes for some of them. Take that, maybe adjust it slightly for your requirements, and use a standard implementation. I think it's been relatively rare that you're actually going to write your own PTF fully from scratch. However, you know, I recognize some of you might want to do that just for your own curiosity, or in case you do encounter another scenario, or you can come up with another general use case this is relevant for. So what I want to do is just kind of walk through briefly how we might actually do this. So how do we actually create a PTF? What do we need? Well, there's 2 key things you need. You need the function itself, but you also need a package, which is the engine for your PTF. So what I'm going to do is just walk through how to create a PTF, which is going to add some columns to our result set. So first thing, we're going to create our package, our add columns package. In there, we need a describe function. So this tells the database what the result set is going to look like. So we are passing into this a table. You can then suppress the columns that you pass on that table, so hide them from the result set, or you can add new columns to the result set. In this case, I'm just going to generate some new columns. So here, we're passing a list of columns here to that. Next, we've added those columns. We probably want to stick some actual values in them, right? So each row, you want to have a different value going in there. We need a fetch rows procedure to do this. This tells the database which values are going to go in each row for those new columns you've created. This is technically optional in that you can write PTFs which don't use it, but it's, I struggle to think of real world examples where you wouldn't have a fetch rows procedure. Maybe if you were just excluding columns, you don't really need it, but whenever you're adding columns, you're going to want different values for those rows, right? So you're pretty much always going to have a fetch rows procedure. Okay, so that's the package. Next thing you need is the function itself. So this looks a little bit like your standard pipeline table function, but there's a couple of interesting things going on here. First up, look at the data types of the parameters we're passing. We're passing a table and some columns. And it's like, what does that mean? Or what's going on here? Well, when I say a table, we really are passing an actual table to this function. You supply the name of the table, and that has to be one of the parameters or to the PTF. Otherwise, the whole thing is not going to work. Now, do you know, when I say table, it doesn't have to be a real physical table. It usually will be, but it can be anything which returns a table. So this could be other table functions. You can't nest PTFs inside each other, at least not directly, but you can pass other table functions. It could be a view. It could be the name of a common table expression, so something you put in your with clause, and you pass that in. So there's numerous ways you can pass a table to this. Note, you can't actually pass a subquery directly to it. You can't say select star from blah as part of this, as this parameter. You want to do that, you've got to use the with clause, common table expressions to define your subquery and then pass that in. So we're passing a table, and what I'm going to do here, it's not something you're always going to do, but I will in this case, is pass a list of columns. So again, here we're saying columns. I'm going to pass a list of identifiers which will become the names of the columns we're going to add to the result set. So we've got our table and columns. Next, let's just look a little bit about the return type. So we've got the table pipelined, and we've got this polymorphic clause. So this could be row or table polymorphic. So row at a time, row semantics means we're processing each row one at a time. We consider that each one independently. They have no influence on previous or past ones. With table polymorphic, we process rows as a set of rows. This is going to become important later on, so bear this in mind. And then we are saying we're using that package. So we're binding this function to that package we just created. So that's kind of the overview. I'll jump into a little bit more details about what we're actually doing here. Any questions or comments on this before I get going? Anything you want to say, Stephen? Or
no, I'm just learning along with the rest of us. Here we go. Can we define the function inside a with clause? Sven.
Can you define the function in? You mean like? I don't know, but I suspect the answer is no. I would have to check that, but I suspect no, Sven. It's an interesting question. Any other questions at this point, or shall I get on?
I'm asking Sven to try it out for us and give us an answer before the session is over. It seems like the least we can do after asking all these questions.
Yeah.
Thanks, Ben.
Yes, I think that's a good call, Stephen. Okay. All right then. So I'm going to talk through the describe function here. So here, what I'm going to do is I'm going to pass a list of columns, and I'm just going to have those added to the result set. So what I need to do is loop through those, and we're building an up array of new columns that are going to be in the result set. And we make these new columns with this lovely dbms tf metadata t procedure. Important thing we need to note here is you've got to pass the name of the column that you want. Unsurprisingly, you've got to call your column something and its data type. PTFs support pretty much all the kind of standard data types in Oracle database, so number, varchar, date, timestamp, raw, so on. Also clob and blob work as well. So pretty much all the standard data types work as column types that you can supply. Having defined that, having looped through all those columns and built up that array, we actually need to tell that database what the result set is, so we return it. That's what we're returning. Describe here returns those new columns to the database, and this is pretty much it for our describe function. We've just looped through that, built up our array, pass it back to the client. So now when we call our add columns PTF, excuse me, I'm just passing in a lovely dual table, and we can see we've got a list of columns. So here I'm just adding one column. I can also add a second column like this, and I could keep going. These columns could be called whatever I want, subject to use standard Oracle database naming rules, and up to the 1,000 column limit for a table, pretty much. So we can keep adding those on there. So this is it's kind of nice, but it's a bit pointless as well at this point. What's the point of writing a PTF just to add some columns which return null? You could just select null, right? This seems a bit daft. We actually want to stick some values in these columns that we're creating. And that's where the fetch rows procedure comes in. So what I'm going to do for this is, again, keep it pretty easy, just to kind of help you understand what some of the concepts are. Each column is going to have an incrementing number, and it's going to be the row number times the column number. So column 1 will have the values 1, 2, 3, 4. Column 2 will have the values 2, 4, 6, 8. Column 3 would have 3, 6, 9, 12, and so on. So we're going to build those up as we go through. And I see comment something Stephen said. Attendee messaged me that you can use the function inside a with clause. We'll verify the post session. Yep. Okay. So thanks to whoever it was who verified using this in the with clause. All right then. Any other questions or comments before we jump into what's going on in the fetch rows procedure? No. Okay. All right then. So each column is going to have an incrementing counter. Oh, so Niels, can you only use it inside a with clause, or can it also be defined there? Yeah, defining it is what I'm not convinced about, but Niels, so maybe Sven could answer that, or maybe someone else can test whether you can define a PTF inside the with clause.
We'll definitely post out the answer on Twitter afterwards and provide a script to verify it.
Yes, yes. All right then. So let's dive into this fetch rows procedure. So there's quite a bit that's going to be going on here. So the first thing I'm going to be doing is getting the environment. So this gets the row set that we're actually processing. Now there are, some of you played with PTFs may know that there's another way we can get row set. There's a get row set function. I've chosen to get the environment here for a couple of reasons, partly to demonstrate that it's possible, and there's always more than one way to do things when it comes to development, but also this environment variable is something that's actually going to become kind of handy later on, so bear this in mind. And this stores pretty much all the execution state of what's going on inside the PTF. And critically, this stores all the columns that we've added to the result set. Now, this is where things start. I say start, and probably already are a bit confusing. This is where I got completely confused for quite some time working with PTFs. We can see here we're working through put columns. If you've looked at the docs, you might have noticed that there are get columns and put columns, and it's a bit head scratchy over what the difference between them are. Get columns are ones that you are retrieving from the table. You are getting them from the table that you passed to the PTF. Put columns are ones you have added to the result set. You have put them on the result set. So get columns are the original, put columns are the ones you've added. It always takes me a minute or two to double check and refresh on this, but you're getting the originals, you're putting the new. Hopefully that will help clear this up for some of you. And I want to put assign values to these new columns that I put on the results. So we need to loop through all of those. And for each column, I then need to go through all the individual rows and actually say what the values are. So for the row count, I need to loop through those. And here what I'm doing, col is an associative array, and it's an array of the rows. And the data type of this will be, there's some predefined data types in the DBMS TF package, has to match the data type of the column that you're actually using. So this is going to be a number here. As we can see, we're multiplying the row number by the column number to give us those incrementing counters. So row 1, column 1 is going to be 1, row 1, column 2 is going to be 2, row 2, column 2 is 4, and so on. So we've assigned all our values to the rows for each column. We actually need to tell the database what those are. We need to actually return them to the client, and we put those on the result set. So the column position, so whichever column that we've added to the result set, we're assigning all the values for those rows. Some of you might note here, I've got like a double loop. I'm looping through all the columns and then looping through all the rows. So this potentially, if we're going to add on 20, 30 columns and have thousands of rows in our table, this may not be the most efficient way of doing this. There might be better ways of doing this. I'm pretty sure there are, but it's just to kind of give you an idea, something quick and dirty to get us going. So we can do that, and when we call it, we can now see we're getting 2 columns, adding to the result set, and column 1 has 1, 2, 3, 4, column 2 has 2, 4, 6, 8. Pretty reasonably straightforward, and hopefully you're kind of still with me more or less at this point. Any questions or comments at this point?
All quiet.
All quiet, yes, all quiet. All right then, I'll keep going, and we'll still be keeping an eye on the chat anyway.
So, Chris?
Yeah, oh,
yes, Niels. The question, the table tab has only one field named X with values 1, 2, 3, and 4.
So yes, okay, yes, good question, Niels. So tab is my table, and it is a 4-row table with the column X in it. That's correct. So yes, this could be a real table, could be, you know, with clause or whatever, but it has those 4 columns in it, 4 rows in it, and the column X, and the columns C2 and C1 and C2 are the ones I've added. So good question, Niels, thanks. Okay, so following on from this, we are passing that table in our tab, and we haven't actually defined how we're walking through our result set. So hopefully all of you know, if you write a select query without an order by, well, then the result set's undetermined. You don't know which order the rows are going to come back. They could come back in any sequence. It just so happened in this case, I've got the X values 1 to 4, but it could go 3, 2, 4, 1, or something like that. So how do we ensure that the order, you know, we've got the incrementing X values, the column values we're generating also match that? Well, we can also pass an order by to the table itself. So this tells us which order we're going to process the data set. Okay, so we're passing our table sorted by our column X, but here I've done it descending to show you that it does flip how it's processing. So you can see that the X values decrease, but the C1 values and actually the C2 values as well increase. So we use the order by, tell the database which, you know, how to walk through the data that you're actually processing. Okay, so notice a little question come in. In place of tab, can we also use another pipeline function? You can pass in a normal table function instead of a table. You can't pass in another polymorphic table function, at least not directly. If you want to chain PTFs on top of each other, you have to use the with clause. So say, have the first one, common table expression returning add columns, and then the result of that with clause pass into another PTF. So does that help answer your question, Swadin? I hope I'm pronouncing your name correctly there. Yes, okay, cool. Okay, so question from Patrick. Can you dynamically add the order by, for example, in the open procedure? Good question. The answer is I don't know. I'm not sure if you can do that. So a bit of background for some of you who aren't aware. I mentioned the describe and the fetch rows procedure. There are also some other kind of standard procedures you can create in that package. Open, close, there's a couple of others which I forget. And the open starts when you actually open the cursor to start processing the result set. So you can do this to do setup and tear down tasks for your PTF. Can you use that to add the order by? Don't know, but you I'd have to check that. Can you, question from Judith, can you order by one of the put columns? That's another interesting question. So one of the columns you've added to the result set. Again, I don't know. I'd have to check that. I suspect no, because if it's a new column that you've defined, it doesn't actually exist at the point you're passing it to the PTF. So the function doesn't have it. So Patrick, not the table passed in. I'm not sure what you mean by that, not the table passed in, Patrick. So yes, so Judith, yes, you can use the put columns in the where clause. That's at that point, the columns, so the columns we've defined C1 here is now part of our result set. So this is our, if you think about standard SQL, how it processes the from clause first, which defines the columns that you're going to be in the result set, and then the where clause. Well, we've processed the PTF, so we've defined what the columns are going to be, so then the where clause comes after that, so we can access them. However, we're passing these, actually, you know what, I've got some stuff up. I've got SQL Developer up here. I will bring it over in a sec, and let's try some of these things out.
And Sven has just reported that using a column which is not in the original table gives you an ORA 62568, invalid use of partition by or order by clause.
Yeah, okay. All right then, so that answers that. So thanks, Sven. Yeah, as I suspected, because at that point, they, you know, these are columns for the original table, and how you would order by something that you've added and then assigning values for to order by it. I don't know how you do that. Yeah. Okay. Yes. Okay. So yes, as Patrick says, you can do it in the final order by. You can do it in your standard order by clause. Yes. Good point, Patrick. Okay then. So we've said we can order by. Now, those of you familiar with analytic functions will know there's something else you can use, which is called the partition by clause. You can also do that with PTFs, and we can partition the result set. So here now table has two columns in it, X and Y. So tab is, again, it's 4 rows, X and Y is 0 for even values and 1 for odd values. And notice that the C1 values reset for each new value of Y. So the counter restarts again for each new value of Y. For each distinct value in the partition by clause, you get a new result row set. Thing here is I haven't actually changed my fetch rows procedure in any way whatsoever. This is all stuff you just get for free as part of the implementation of PTFs. So you can carve up your data set into groups. So you could do top N by group using PTFs pretty straightforward, pretty easily. Whereas without having to actually change your function at all or in any way. So you can order and can partition. If you are writing a PTF, which depends on walking through your data in a particular sequence, you need an order by. If you don't, then it's up to you how you actually process it. And again, partitioning by carves up your data. Any other questions or comments on this? Okay, I'm not seeing anything coming in the chat at the moment, so I will move on. Okay, so this is, as I said, partition by, order by is something that you get for free. So far,
Chris,
yes?
A question regarding the partition by.
Yes.
That means that the fetch rows procedure will be called for every value of y, one after another, or?
Are they called sequentially or not?
Or in parallel? I mean, for every value of y, the fetch rows is called so that you have, that you know how much rows belongs to the value of y.
Yes. So that kind of leads on to the next point I'm going to make, Niels. So exactly how the internal processing, are they processed sequentially or in parallel? I don't know. I mean, when it comes to parallel query processing in general, it probably helps, but I haven't tested, so I couldn't say for definite. However, the point you've raised about, do you know how many rows you processed, is an important one, and I'm going to come to now. So,
and Chris,
yep, sorry.
We've got a comment from Joseph that it's important to note that fetch rows is called once per distinct partition key value when using partition by.
Yeah. Yes. Yes. Great point, Joseph. So, however, it's called at least once. So far, I've just been processing 4 rows. Let's imagine we've done this add columns and it's got thousands of rows in the result set. At some point, you're probably going to hit something like this. So we've got our X values that keep going up and up and up and up, get to 1024, get to 1025, and mysteriously, our C1 values have reset back to 1. And it's like, interesting. What is going on here? So the fetch rows process or procedure processes rows in batches. So imagine we passed in a 1,000,000 row table. It doesn't really make sense to process all 1,000,000 rows in your PTF before returning anything to the client. You know, there could be memory implications doing so, and of course, it then becomes a blocking point in your plan. It stops later steps in your SQL query actually doing anything because we haven't passed the rows back out. So we process the rows in batches of 1024. Now, note this 1024 limit. I don't know if this is a fixed limit or it varies in any way. In the testing I've done, it's always come out at 1024. Certainly, there's nothing you can do as a developer to change what this limit is. It's possible that we do some stuff internally to change based on the size of the table that you're passing to it, for example. So this definitely happens at least every 1024 rows. It could happen more frequently, so do bear this in mind. I need to speak to the developers to find out exactly the details on this. So if we want our C1, C2, etc. values to continue incrementing, so when we get to 1025, C1 is then 1025 and so on, how do we do this? Well, we have to save the execution state. So you need to process that first batch of rows, save the state of where you've got to, and then continue for the next batch of rows. And the now, the first thing some of you might think of, we're going to save application state. Let's use some package level variables, because that's a neat way of saving package state. You can't do that, okay? There is actually something that says in the docs, don't do this, it doesn't work. And from experience, my own experience as well, don't do this, it doesn't work. You can't use package level variables to save state across these fetches. What you need to do is use the execution store instead. So before I get to that, Patrick's had a question. Can you tell in any way that there will be another batch? So good question, Patrick. And it's not that I'm aware of at the moment. Other people have asked about this. And as far as I know, in the current implementation, you can't tell whether you've reached the end of the result set so far. Obviously, if 1024 turns out to be a fixed limit and you've got 500 rows, well, you've at the end of that, there's nothing more to do. If, however, the number of rows you're processing happens to be an exact multiple of 1024, do you have another row to process or not? I don't think we have a way to tell this at the moment. It is, I believe it's something that we're looking at, though. It has a question that comes up before. Okay, so return where we were. So if we get to our 1025th, we get to our 1024th row, we need to save the state of where we are. So we've got our incrementing counter. We need to save where that counter has got up to. And we can do this with the execution store. So dbmstf execution store get and set. So this is a simple key value lookup repository. So what I'm doing is saying for each column we put on the result set, 1, 2, 3, 4, I'm getting a key value, column 1, col 2, col 3, col 4, and so on. So based on this loop. And I'm getting which row we've fetched so far. What is the last row we've reached in the result set? Now note, if this is the first execution, then obviously that key doesn't actually exist. It will initialize, doing a get initialize this. So you don't need to do some kind of check if it exists, do a set, then do a get. You can just call a get straight out the box. So your first pass through will do that. However, you will need to initialize your last row variable to 0, or any state variables that you want to maintain. You'll need to initialize those. And it's an in-out variable. So the variable value doesn't exist. It retains whatever you initialize it to. If we've got to the 1025th row, it'll get that key for col 1, col 2, and assign it to the last row. We then loop through the process, adding that to our row count, and then when we've finished, we need to set it again so the next execution through will access that. So, questions, comments on that?
Well, I do have one question from Patrick.
Yes.
Can you tell in any way that there will be another batch? It's not related specifically to this, but
yeah. As I was saying, as far as there isn't a flag or anything saying we're at the end of the batch. Other people have asked about this, and I believe the developers are aware of this, and I believe they are looking at finding something which will allow you to do this, but currently there isn't a way to say, yes, we're at the end. So, you can infer that to some degree by, if you've fetched less than 1024 rows in the current fetch, then yeah, we've reached the end of this partition in the data set. But in general, no. Any other questions or comments on this? Okay, so, yep, thanks. Okay, Judith, it looks to me that you call dbmfx store get with non-existent key name, it will probably return null. So it will So this second parameter here is an in-out parameter, Judith. So if I've not initialized last row, then it will, yes, it will be set to null. However, if I have a statement before this, which sets last row to 0, for example, it will still retain that value. It's not going to put this to null. So it's, actually, I'll bring up my real code in a second. Let's see, where's my real code? If I bring over SQL Developer, you can see I've initialized last row to 0 here, and then in my get, I've done this. Now, because on the first execution of first call of that fetch rows, this value doesn't exist. This retains its value of 0. It does not overwrite it with a value with null. Okay, so does that clarify, explain there? Okay. Okay. So let's move on a bit. So this is a hugely powerful feature, and I'm sure some people are going to come up with some brilliant or interesting ways of using it. And with great power comes the ability to get yourself completely and utterly stuck, right? So the question then becomes, well, what do you do? You know, how do you debug this? How do you resolve this information? What is there to help? So there is a trace procedure in the TF package, and this has a number of overloadings to help you see what's actually going on. Two, which I found most useful, are the end and the message. So if you remember when I was talking about the fetch rows procedure, I said the first thing I did is I got the environment. One of the reasons for that is partly because it gives me all the row counts and column counts that I need to do the later processing, but also I can then just stick that in the trace. So the first time you write a PTF, I thoroughly recommend you include somewhere in the fetch rows a full environment trace, because this makes it a whole heck of a lot easier to figure out what's going on, because it will show you all the columns that you've got, put, and so on, and a whole bunch of other information. So this makes it much easier to help you see what's really going on. The message tracing is just, you know, you put your whatever text so you can output your variables. Note these kind of are, in a way, and I suspect that they probably are, just wrappers for DBMS output. So the tracing information will go to your console. So like if you've got DBMS output, you need to have a client which actually displays that information and a server output on and so on. Same with the tracing. If you are using this in an environment which doesn't show you DBMS output information, you will not see the trace information. So do bear that in mind. Okay, so comment from Patrick. Can you turn tracing on and off without commenting them out? Other than passing a parameter, you know, include trace true false, I don't think so. I'd have to check that, Patrick. I don't think there's like like DBMS output has an enable and disable. I don't think there's a trace enable or disable, but I'd have to check that. So I'll follow up on that. Going back up, Judith, yeah, yes, the XStore get, yeah, it is a little counterintuitive. Yes, I kind of agree. So yeah, that's worth bearing in mind. Any other questions or comments on what we've covered so far, or PTFs generally?
Just to note, I see nothing in the DBMS TF documentation that gives you the ability to turn trace on and off.
Yeah, thanks, Stephen. Yeah, I've not noticed anything either. So yeah, I think if you want to toggle it, you'll have to include your own parameter toggle one way or the other. Okay, so with that's kind of the basic add a column, add an incrementing row count. Now, it's worth saying, so far everything I've shown you, you could do just by using the row number analytic function. And for what I've shown so far, I would almost certainly use that, right? Because it's easier and much less coding. But it does help demonstrate a lot of the principles, how you can sort the partitioning, how you assign the values, and so on. If you want to see some more complicated example, as we see, we've got a huge, huge stack of examples already in LiveSQL, which walk through various examples. Excuse me. Some of the things I mentioned at the start, the dynamic CSV to columns converter, we've got an example of showing you that. So you can see, let's just make this a bit bigger so you can see what's going on. So we've got 2 comma separated values, as for 2 columns, split them out, can pass in 4 columns like this, get those out as 4 values. Now, some of you might be looking at this and going, well, with the previous example, I passed in those columns. I had the columns, keyword, and an operator, and I passed a list of identifiers. But here, I'm just passing a string of what I want those columns to be, or what I want them to be called. So why have I done this here and used the columns in the previous example? Why would you use one or the other? So first thing to kind of bear in mind is if you use the columns operator, the values you pass to that have to be identifiers. So that means they cannot be bind variables. You can't pass a list of bound column names to the columns operator. So if you want to use variable, actually have a variable here to pass in what the columns are going to be, then you can't use the columns operator. So something to bear in mind there. And with this CSV processor, my conceptual thinking behind it was you have got a CSV file. The first line in that is a header row saying what all the fields are called. So the first thing you do is just read that header row and then pass that as the column names. That would probably be a variable in like a real world scenario. Again, you can't do that using the columns list. So when would you use one or the other? It's always the kind of, it depends. If you need a bind, which is going to say what these are, then you're going to have to pass a string, a comma separated string, and do splitting. The advantage of using the columns operator is you can get a lot of information about them, such as you can do things like have data types for them. So the columns you pass, they could be new columns, but they could also be existing columns that are already in the table. So you can do things like look up their data type and see what they are. So, which you use kind of depends on your use case and what you're trying to do. We've also got dynamic pivot. This is a bit more complicated for obvious reasons. But so far it just does a count. And so I've got a query here, which is going to pass in the list of values, which are going to become the columns. And using the classic employees table, we spit out how many employees have each of those job titles. So here we can see we're getting everything in the table. All this stuff here that you're seeing, that's all that trace that I was talking about. Now, most of this is my own debug, but towards the bottom here, all this stuff is the stuff that you get in the environment. So we can see what all the columns are, their data types, and so on and so forth. So that environment tracing gives you a whole stack of stuff. We can also, I've restricted it to a couple of departments, so we've got fewer job titles, so we get fewer columns in the result set. So you can see we're passing a query, tells the database which columns are going to appear in the result set. Okay, any more questions, comments, thoughts on this? Anyone actually using this in the real world that, or think of other real world examples to use this for?
Just to repeat that question, have any of you actually built polymorphic table functions that you're using in your applications now or plan to?
This is the real test.
You can even unmute And shout out your success and enjoy. Sven
Not
says
yet,
90.
Sven. Does that mean you're planning to, Sven? Or you've got something that you're actually... a sum interval function. Yes, sum interval, that would be potentially quite useful because, yes, I can see that would work. Have some ideas. Well, let us know when you get there, Sven, because I'm interested to see what people come up with here. Building a top n plus function. Yeah, I think that would be quite cool. Matrix pivot operations. Interesting. Okay. Let us know when you got there, Sven. So I think maybe for Oracle Apex pivot reports. So one thing worth mentioning here, so you can use PTFs in your interactive reports in Apex, but not with the dynamic column generation, at least as far as I know. So in theory, maybe they'll integrate this and you can do things like that, but currently you can't use the dynamic column generation aspect of PTFs, which, you know, kind of questions why you're using them. You could use
It's the point, yes.
Yeah, you could use a regular table function or something else. Okay, so Niels, as he says here, some interval can also be created by user-defined aggregate functions. So that's a good point, Niels. However, the kind of answer to that is that PTFs, or the idea behind PTFs is that they are aggregate functions done right. Okay, so these really should supersede the custom aggregate functions that we currently have today. So a lot of the things that you could do with a PTF, you will be able to do with a custom aggregate, but PTF should be the preferred way of doing it from 18C onwards. We should tell Joel to implement it. Okay. Well, yeah.
Well, that was a message to everyone. In other words, the community should tell Joel.
Yes.
The Apex community listens to the members of the Apex dev team listens to members of the Apex community, not so much from us developer advocates.
Yeah.
With all due respect, with all the respect that should be applied to our users.
Exactly. So customer requests get higher priority than our requests.
And seriously, if you are using Apex and you do have a use case where you would like to have had that dynamic column generation, I'm sure it's nothing new to them. Anyway, letting them know about it either through a Twitter or a direct SR or email, plus the fact that we now have the polymorphic table functions to back them up, means that there may be new possibilities.
Okay, yeah. Yes, they do that. Okay, anyone got any other questions or comments? Judith, aggregation can, however, become a little cumbersome when you have to keep track of the middle values because of the batch size limit. Good point. Yes, and that execution store, particularly if you're doing some quite complicated things, could get very messy. So that's a good point, Judith. Okay. Anything anyone else wants to add, say? Oh.
And these could be questions about polymorphic table functions or PL SQL generally or SQL Oracle database, whatever's on your mind.
Yes. What's on? Well, do we want to know what's on everyone's mind? Maybe not.
Well, we can take it out of the recording later.
Yeah. Fair enough. Yes. Okay. So what do people think of PTFs? Does this seem like something you're actually going to use? Just too weird and crazy and unlikely to ever see the light of day? I'm curious what people's thoughts on this are.
And feel free to unmute if you'd like to talk.
Yeah. It's cool, but mind-boggling. I can agree with that, Patrick. I must admit, I've played with these off and on for pretty much since 18C come out. And I'm still just getting my head around it. So it does take a fair bit of playing with. Wild and wacky use cases. I'm so curious. Yeah.
So I think the takeaway is if you find yourself thinking about a wild and wacky use case, whatever it might be, think about polymorphic table functions as your solution.
Yep. Yes. So actually, you just said you can't think of not seen any examples which add new rows. So we do have an example of that does that in LiveSQL. Let me check. Is this one of them? So one of the things you can look at, there's a row replication factor parameter, which allows you to duplicate or say how many times a row appears in a result set. And does this one do it? I think, does this one do it?
I see it called a row replication.
Yes, row replication true. When you describe the result set, you've got to set that to true. And that then you have an array of numbers which says how many times that row appears in the result set. And we see we set the replication to 6 and just passed in, I'm not sure where he's created a view over dual, but anyway, okay. That is then generated 6 rows from 1 in the original data set. So the row replication is what you need to look at if you want to add more rows. And you can do that for each individual row. You can say this row appears 0 times, the next row appears 3 times, the one after it appears twice, whatever you want, really. So, yeah.
We've got a comment from Sven. Some languages did look down upon PL/SQL because it had no support for polymorphism. So it takes the wind out of those arguments, but I find the use cases to be extremely rare. I should say some architects from other languages said above. And just one thing to point out there, PL/SQL does support polymorphism from the standard object-oriented perspective of polymorphic overloading, so that essentially dynamic overloading, so that the time that you're invoking the method, it will automatically climb up the hierarchy of object types and search for the best match, which is polymorphism.
Yeah. So thanks, Stephen.
So there's a different kind of polymorphism. Now we've got it all.
every kind of polymorphism you can dream of. Yep. So Judith, you're following up. Yes, but replication existing rows is not the same as creating genuinely new rows. So I don't think there is a way to create genuinely new rows. As far as I know, that's not possible, at least not currently. Let's see, there's some other comments back fairly in the thing. So Joseph saying currently only non-leaf PTFs are possible. Would love to see leaf PTF support. Yes, that's something that's coming at some point. So you have to stay tuned for this. First I've heard of this, so I'm still suffering from PTFD. Yes, okay, that's probably fair. Good, fair comment, Bill. Does take a bit of wrangling. So Niels, do you have an example of row polymorphic you mentioned at the start of the presentation? So I think some of the examples in here are row polymorphic. One of the key, or one of the big differences between row and table polymorphic is you can't use the partition by and order by clauses for row polymorphic PTFs. So if you need anything which you want to do the sorting and the partitioning, you have to use a table polymorphic function. That is the key difference I'm aware of. I'm sure there are other more subtle differences which I don't fully understand yet. But if the function you're writing doesn't need sorting or partitioning, then there isn't a huge amount of difference that I'm aware of. Okay. Describe T has a Boolean field named row insertion, maybe for future use. Yeah, I think there are still some unfinished features on PTFs, and as Parachute says, row insertion doesn't work yet, so definitely for future use. Yes, there are still some things that need to be finished off with PTFs. So if you are building one, make sure you test very thoroughly, because you might find some edge cases which we need to finish off the implementation for. Sven, instead of package state, can we use application context, syscontext to store values? Good question, and the answer is maybe. I think the key thing is that each partition for your fetch rows, each partition runs its own fetch rows instance. And if you're doing things with package state or application contexts, I believe they can clobber each other, which is one of the fundamental reasons for using the execution store. So yes, you're saying you can do both of these, but you will run into problems. I can absolutely assure you, if you try and use package variables to maintain state, it will create issues. And then there's a line in the docs explicitly calling this out as well. Yes, that's Patrick. I think, why would you do this instead of the XOR? I think maybe because that's what people are familiar with. And if you're a PL SQL developer who's been around for a while, how do you maintain state? You use a package variable or the application context. And I think, yeah, nobody's familiar with PTFs. Well, maybe we're all a little bit more familiar with PTFs. Hopefully, you've got that little bit extra. Something
little by little.
Yeah. So, this is quite new and it is a lot to it. So hopefully we're getting there slowly. Hopefully, yes, Santa says, yeah. There are some examples. Yes, Daryl Hurley's got a lot of good examples. Several of the ones here on this on LiveSQL are actually from Daryl, as you can see. So there's several. Patrick's got a couple as well. There's a few which are from Oracle. A lot of these link back to things in the docs as well. So Victor, hi, thank you for the explanation. Can PTF be used in a read-only database? Let's say we use them launching reports on Active Data Guard database. We use Data Cartridge now to achieve the same results and cannot use this technology in Active Data Guard because of some issues. Good question. Short answer is I don't know. I would have to test that out and find that out.
Well, in a read-only database, you definitely can't create standalone packages and so forth. As far as I understand, that was one of the use cases for the with clause in SQL with function, is that you could declare a function on the fly and not have to do a create or replace. Yeah. So it seems unlikely.
If it already exists on your source database and you're just calling it, it's probably one of those where it depends on what you're doing, I suspect, is the answer.
And here's a message from Sven. By the way, I failed to define a PTF function inside the with clause. And I tried to do the same thing and was getting syntax errors. And then he says, but I didn't even manage to create a package in the with clause, which might be a syntax issue. Yes, as far as I know, you can't create a package in the with clause. No, you can create a procedure that will then be called by a function in the with clause that is then invoked in the select statement or the SQL statement. But I don't think you can create a package. And really, I think that's a fine point. Don't create packages in the with clause of your SQL statements.
Yeah. It's kind of questionable about what you're doing, isn't it?